Hello everyone, welcome back to Coding with Mock. And in this video, we'll be looking at the Java thread lifecycle again, but we'll be looking at a more advanced lifecycle this time. So we'll start out with looking at the basic lifecycle, as we already have seen. So to begin with, we create a thread, either be it using a class that extends from the thread class, or a thread in which we inject a runnable using a separate class with the runnable interface, or a lambda expression derived from the runnable interface. And we create a new thread object. Now this object will start out in the new state. Our thread is just created, it's new, but it doesn't do anything yet. It's just sitting there in memory, not doing anything. Now, to get our thread to run, we have to call the start method. Now remember, calling the start method only puts our thread in a runnable state. It doesn't actually start running yet. The actual running of a thread is not up to us as developers. We can just say this thread is ready to be run, but we can't actually get it to run. That job is reserved for the scheduler. And as we've already seen, we have little to no control over the scheduler and how it works. Okay, now that's not really important for now, but just remember that even though we put the thread in a runnable state, that it's the scheduler that has to actually get it to run. Okay, now when our thread has done its job, and that job being defined by everything that we put in the run method, if we exit the run method, or when the run method has run its course, that's when the thread itself will be putting the terminated flag or the terminated state onto the thread object. And that's when it's basically done, signifying that this thread is finished and can't be run again. Okay, let's take a look at a more advanced lifecycle, or more extended lifecycle, if you will. A lifecycle with a sleep built into it. Now, it's just an extension of the lifecycle that we've seen up till now, so we'll still have our new our thread that's been put into the new state when it's created. Then when we call the start, it's still getting put into the runnable state, and when it's finished, it'll put itself in the terminated state. But we've also seen that we can put a thread to sleep, calling the sleep method, the static sleep method on the thread class. Now, this makes your thread stop working for a certain amount of time. Now, the thing that you need to remember here is that when you call that sleep method on a thread, is that that thread gets put on a timed waiting state, right? So your thread will be waiting until the timer runs out. There's about, if you call it for 500 milliseconds, it'll wait for 500 milliseconds and then start running again. Now that's not exactly correct what I just said there. What happens is a runnable or a running thread on which you call the sleep method, that gets put into a timed waiting state. Your thread starts sleeping or starts waiting. Then when either the time is up, or, and that's also something we've seen, you can call the interrupt method. And if you interrupt a sleeping thread, you interrupt the sleep, not the workings of the thread. That's when your thread gets put back into a runnable state. It doesn't return to running yet. It returns to the runnable state. That's important to remember. What's the difference? Well, the difference is, it's just as we call the start method on a new thread, our thread in the runnable state isn't actually doing anything yet. It's waiting for the scheduler to pick it up. Okay, so that's important to take into account, is either when we start a new thread or my thread in a timed waiting state returns to a runnable state, it doesn't automatically start running again. It has to wait for the scheduler to pick it up again. Now, there's several reasons why this is the case. In our examples, we've had 1, 2, 3 threads running at the same time. Now, in the next video, I'll be explaining a little bit more about the context of threads and what you need to know about threads as a beginner or a junior developer. Namely, that in the context that we will be using threads or be working with threads, there might be dozens, even hundreds of threads running at the same time. Now, if you have hundreds of threads running at the same time, it's not that obvious who gets to be running, and somebody needs to orchestrate all those threads. Because a thread, as you might remember from our first lesson, a thread represents a unit of work being done on one CPU core. Now, you don't usually have more than 50 cores on a server or on one particular instance of a server, right? That's the thing that you need to remember. Now, with modern CPUs, you might have 128 threads. I think that's about the maximum at this point in time. But still, in a larger context, that means that your application or your threads need to be managed. Okay? Really important to note. So, getting back to our lifecycle, you have a thread in a runnable state. We put it to sleep, calling the thread.sleep method. Gets into a timed waiting state. We interrupt it, or we interrupt the sleep, or the waiting time is over. Our timed waiting thread returns to the runnable state and then waits. It's still waiting. It's in a runnable state, but it's waiting to be picked up by the scheduler. Okay? Then, once the scheduler says, you're fine, you can start running again, that's when it gets back to work and hopefully will end in a timely fashion and get back and will finish up at the terminated state. Okay, so that's the sleep lifecycle. Now we'll be looking at 2 more lifecycles, which are not that different. They're actually quite similar. Let's have a look at the synchronized lifecycle, the lifecycle that we've looked in the previous video, where we had a shared resource. And when we had a shared resource, we had to be careful that we didn't have multiple threads accessing that shared resource at the same time. But that means that we have a new state in the lifecycle. So the basic lifecycle is still the same. We have new runnable and terminated states. But now, when our thread comes to a synchronized code block or a synchronized method call, and that synchronized block has a monitor object, and that monitor object is, let's call it blocked, or it's taken by another thread, that's when my thread has to wait. Now, it doesn't get into a waiting state, it doesn't get into a timed waiting state, it gets into a blocked state, right? So there's a difference between a thread in a timed waiting state or a thread in a blocked state. The timed waiting says we're waiting for a certain time interval to pass. A thread in a blocked state says I'm waiting for a monitoring object. I'm waiting for a token to enter a synchronized code block. Okay? So that's really important to note. So a thread that is running comes to a synchronized code block, then asks the scheduler, I need this monitor object to enter the synchronized code block. The scheduler says, nope, you can't. There's the token is taken, or another thread is inside the synchronized code block. You're gonna have to wait. That's when that thread enters a blocked state. Now, when the monitoring object is freed up, so the original thread that had gotten or acquired the monitoring object from the scheduler is finished with its synchronized code block, it'll free up the monitoring object or return it to the scheduler. Then the scheduler will be looking at all the threads that are blocked and waiting for that monitoring object, and then randomly assign it to one of the threads that require it. So that's also important to note. There is no LIFO or LILO, so the last in, last out, or last in, first out ordering of threads. It's a little bit random. Your scheduler should have a heuristic algorithm within itself to make sure there are no threads that wait too long, but we have no control over that. Just to put that out there. Okay, now, so we're in a blocked state, our thread is in a blocked state. The monitoring object returns to the scheduler. Your scheduler then looks at all the threads that are waiting for that monitoring object, picks one, hopefully ours, then gives that monitoring or assigns the monitoring object to that thread, and our thread returns to the runnable state. Then the scheduler looks at a lot of factors, one of which will be, is there a core free on which this thread can be run? And if so, your runnable thread will actually start to run. Okay? That's how the blocked state works. So we have still new runnable terminated, or runnable gets to a synchronized block, has to wait for the monitoring object. It might be possible that it immediately gets it, then it stays in that runnable state and just keeps on running. But if it has to wait, it goes to the blocked state. Once it acquires the monitoring object, it returns to the runnable state, doesn't start running yet. And then hopefully the scheduler will pick it up in a timely fashion and allows it to, or allows your thread to start running again. When it's finished, returns to the terminated state. Okay. That's how that works. Ooh. Now, the last life cycle, and that's something we haven't seen in a previous video, but I encourage you to look at this in your own time, namely the wait life cycle. It's a little bit more involved, but it has the same features as all the previous life cycles, but it's just a little bit different and uses a few other words. Okay, now how does this wait lifecycle work? We still have the new runnable and terminated states that we had from our previous life cycles. Those are still the same. But now what is possible, or a new possibility that we have, is that when our thread that is running is in a synchronized block, and let's say that our thread needs another resource, but that other resource isn't available, or some result of a calculation isn't available yet, so we want to wait. Now, you don't know how long this might take. The result might be there in 1 second. The result might be there in 5 minutes. So you don't have, it's on another thread. You can't really calculate how long it's going to take for your needed resource to actually be available. So what you then want to do is you don't want to hold on to that monitoring object, because you're holding a monitor object and you're blocking a lot of other threads that might have all the resources they need to actually finish their run. So what you want to do there is you want to release the monitoring object, but you don't want to reset your thread. Now, what Java then makes available to us is the wait method. Your wait method will put your thread on hold and release the monitoring object. You will still be at a point, or your thread will still be at a point within a synchronized code block, but because it's not running anymore, it's going to go to a waiting state. Because we're in that waiting state, we don't actually need the monitoring object anymore. And we will be releasing that monitoring object. So that's what happens when you call the wait method in a synchronized block. We get put into the waiting state, or your thread is going to be put in a waiting state, and it will be releasing its monitor. Okay, now, because we don't know when our resources will be available or when our result will be available, we don't actually know when to wake up our thread. Now, that's something you'll have to build into another thread, is to wake up our thread. Now, how do we wake up our thread? Is by calling the notify method. The notify method will wake or alert one of our threads. And that's also one important to note. The notify method alerts only one thread about the availability of our monitoring object. So the thread, one of the threads that has been put into a waiting state, will be woken up and put into the runnable state, but not really. It doesn't start running again because it's in that synchronized code block. We put it in wait in a synchronized code block, so it's still going to be in that synchronized code block. It gets notified, it gets actually woken up. Now, it gets put into a runnable state really briefly, but then once it gets up and running, as it were, that when your thread will realize, hold on, I'm in this synchronized code block, so I need my monitoring object. It'll ask the scheduler, hey, I need this monitoring object to be able to continue. Is it free? Then, if it is free, the scheduler will assign the monitoring object to your thread and then hopefully let it continue running. If it isn't, then we'll have to return to our previous slide and your thread will go into a blocked state. Okay, so that's important to remember here. Or let's just do a quick recap of this new life cycle. We have a runnable thread inside its synchronized code block or in a synchronized method call. Because of some reason, we want to put our thread on hold. We call the wait state, or your thread calls the wait state. That puts your thread into a waiting state. That thread also releases its monitoring object. That gets returned to the scheduler. And your thread is now waiting for something. And that waiting for something, or that something, is a notification. A notification that has to come from another thread. That can be your main thread or another calculation thread, but not this thread, because this thread is waiting. It's not doing anything anymore. It's just lying in bed, doing nothing. Okay? So Once it gets notified and woken up by the scheduler, it returns to that runnable state, but never forget, or don't forget, you're still in that synchronized code block. So you need the monitoring object to continue. Now, if the monitoring object is free, that's all fine and dandy, but you're not guaranteed that. So you return to the synchronized block in a runnable state. The thread will ask the scheduler, is our monitoring object free? If it's free, the thread will start running. If it's not free, that's when we enter the blocked state. Okay. Now, in the next video, I'll be going over what you will need to remember about all of this. About multithreading, about lifecycles as a junior developer. Okay? There's quite a bit of a difference between what you need to know about multithreading as a junior developer and as a, for instance, senior developer. But that's for the next video. Okay? Good day, everybody. Stay safe, and I'll see you in the next video.